Hello everyone, my name is Bhavik, and in this video I will demonstrate my project Smart Intrusion Detection and Lock Control System via IoT and Cloud. So the main goal of my project is to make homes and office doors more intelligent and responsive. My project detects motion, recognizes faces and logs every events along with storing the evidence securely in the cloud and allows me to unlock the door with the help of MQTT protocol as well. So the purpose of my project is to automate the complete process of intrusion detection and door locking. So whenever the motion is detected, the camera will recognize faces that is coming across. So if the known face is detected, then it unlocks automatically. And if the person is unknown, then it triggers an alert and sends me an email notification, along with giving me an opportunity to unlock the door manually if I know the person, but he has not been, his image is not being trained in the ML model. So the purpose is to detect the motion, send instant alerts, controlling remotely as well as event logging for the storage purpose. So the hardware components that are included in my project is this Raspberry Pi board along with the camera, which will recognize the faces. Then there is a PIR sensor, which is the motion sensor, which will detect the motion, and only after if the motion is detected, then the camera recognition will further take place. Otherwise, the camera will not start recognize the faces. It is I have used this technique for the optimization so that the camera does not remains open all the time. And the secondly, I have also used Arduino Nano 33 IoT for the mainly lock control system. Like if the command is unlock, like if the face has been recognized, then the unlock command has been sent to Arduino Nano 33 IoT via Raspberry Pi through the Bluetooth communication with the help of BLE, which is Bluetooth Low Energy. So if the command is unlocked, then the green LED, which is an actuator, which it will glow along with opening the solenoid lock. And if there is an unknown person, then red LED will glow, but the lock will remain in its current position, so it will not open. The overall hardware setup of my project is something like this, where it is here is the Raspberry Pi board, which is connected with this camera module and the PIR motion sensor. Secondly, here is the Arduino Nano 33 IoT, which is this is the breadboard in which red and green LED has been situated as an actuator for this specified purpose. I have connected it through relay module. Arduino, if the command is unlock, it will through the relay module it will send to the solenoid lock, and the power it is getting the power through this 12 volt DC adapter. So this is the overall functionality which we will be looking further how it works. So the network and communication architecture. Here's the overall network architecture. The Raspberry Pi is the brain that connects all modules. It uses the BLE for log control, Dropbox API for storing the images, SMTP and for notification, and MQTT for manual override. Even if one service fails, such as when if there is any urgency, if the user has if the user has not uh, if there is any unknown person, but if the user wants to take that person into the room so that his face is not recognized, so it will obviously recognize him as an intruder. But I have given the functionality that if the user wants to open it, it can be the lock can be opened through MQTT protocol. So, and all the data will be stored in this Dropbox API along with the storage of data in local log as a local loggings, so that in the Raspberry Pi, all the data and the log CSV that from the start, whatsoever person has comes inside, and all the images of intruder has been stored in the Raspberry in the local server as well. So this is the overall system operation. Firstly, the motion will be detected. So after the detection of motion, it will activate the camera. So after the camera is activated, the face recognition with the help of face recognition libraries such as OpenCV as well as face recognition. If the face matches a known person, then the system gets an unlock command, and which is sent to as a signal to the Arduino opening the solenoid lock. If the face is unknown, then it saves the image and upload it to the Dropbox along with sending an email notification to me so that I know who has tried to unlock the door. And lastly, for the storage, all the events have been logged with the full details for audit trial. There are certain fault tolerance mechanisms, so the system is fault tolerant. If any network or Dropbox fails, then the images will still be stored locally, and uploads are retired in the backgrounds to the main program never crashes. And if the BLE disconnects, it automatically reconnect. So when the and along with this, if the if the motion is not detected, so the camera will stop automatically, which saves the CPU as well as the saves the lock from heating. And this is the overall summary. So the firstly, the motion to camera in which the PIR motion sensor successfully triggers the camera upon deactivating. So majorly in this demo, we can see the motion detection and face recognition in action. Here, when I enter the system, it recognizes me and unlocks the door automatically. But when a stranger enters, it detects an intruder, locks the door, and sends the email with the Dropbox link of the image so that I can know who has tried to entered, and I can then remotely send the command of unlock if I want to open the door. Otherwise, the lock will remain closed. So now we will test our project. So now we will look at all the code program files that are required for this project. So my project basically requires only three files. One is for Arduino to control all the lock system as well as connecting with the Python script of Raspberry Pi, and the two Python files. One Python file is this, which is used for training of our ML model, like all the images that have to be recognized by the camera are to be recognized with the help of this file. And the other Python file is used for connecting with the Arduino Nano 33 IoT to send the commands as well as to on the camera by the functionality of PIR Motion Sensor. So firstly, this is encode underscore faces.py. In this Python file, I have firstly initialized various important libraries such as face recognition, CV2, OS, Pickle. Face recognition is the core engine for finding and encoding faces, and OS is used to navigate the file system, and the Pickle library is used to sterilize the final data into binary file. Next is the data directory in which the training images. This is a folder where all my images have been stored that are used to recognize the person. And then is this encoding files, which is encoding.pkl. It is the output file that stores the numerical database of the images. So this script is basically in this script it reads to every subfolder found inside the training images. Like this is the folder of training images, and currently I have only Bhavik as recognized. So there are I have used various angles and various like lightings images so that my image from every angle can be trained and recognized by the camera. So this firstly it reads to every subfolder which is found inside this training images folder. And then for every image file which is found inside the users folder, the script perform various steps. The first step is to find the face through this function. Secondly, it encodes the faces with the help of that encoding.pk, which is generated through this file. And then it saves the data. So lastly, for the data persistent after processing all the images, the script bundles the two lists, which are the name and encodings, into a single directory, and it then uses this pickle.dumps data to convert the complex Python dictionary into a compact stream of bytes, and it saves it as a encoding.pkl, which we can see from here. So this is the file in which all the images with when we put them in the training images folder, so it will be stored, and this file will help us to uh, generate the and recognize the faces. Now we will look at the second file, which is basically doing all the monitoring. And before looking at all the libraries and the things that we have installed, uh, I need to tell that I have used and worked on this code primarily on the Python environment, which is the virtual environment that I have created, and not on the global. environment of the Raspberry Pi terminal because the libraries were too heavy and it were not supported by the latest versions that such as Trixie. So I have set up my Raspberry Pi 4 with the older versions, and then I have created a Python environment, and on that environment I am using all these codes because on the latest environment it was too heavy and I was getting so much of errors. So continuing with our code, these are all the libraries. Some were recognized previously in encode at the rate faces.py. The new libraries are such as the CSV, which we have imported so that our events.csv can be generated. Second is Bleak for the BLE Bluetooth low energy communication between the Arduino as well as the Raspberry Pi and the GPIO pin. This GPIO pin is used to like we have to import so that we can add the functionality of PIR Motion Sensor. Dropbox library has also been imported so that we can store the images into Dropbox API Cloud. These are the configurations Arduino BLE address, character UID, which will connect our Arduino with Raspberry Pi, encoding.file, which we have seen just before. And these are the camera resolutions. These are the storage and logging path. We will also see intruder logs and event.csv further. And this is the Dropbox credentials. Then is MQTT credentials, and there are certain functions which is handling all the functionality like upload to Dropbox, schedule Dropbox upload, as this is the notification function like for the which is the sender email and receiver email, and what is the subject like for there are certain specific functionalities for the non-faces as well as for the intruder, so this will cater these things. Then there is setup function, and lastly there is our main function which is opening the camera if the motion is detected by the PIR motion sensor. Then there is face recognition logic, and it will if the unknown intruder is detected, so it will save the image, send the email, log the image locally, and upload in the background, and send BLE command to the Arduino Nano 33 IoT so that our log system can work. Now we will look at the Arduino code. So this is the Arduino code which is importing the BLE library. Uh, so firstly, these are the pin number of relay green LED and red LED. Then this is the same UID that we have seen in Raspberry Pi. These are the void setup as relay pin, and both the LEDs are output devices. So we have used the pin mode, and initially the relay pin is high means the lock is actuated. It is in its high state and the other LEDs are low. So when the command will come, like here it is. If the unlock command will come, then green LED will become high, comes to high state, and the relay pin will like is switch to low state means that lock will open, and I have given the delay of 10 seconds, which means for 10 seconds only the lock will remain open. And if there is alert command, so red LED will earn and lock will not open. So after this we will look at the functionality of our, like we will test the system like how it works, and I will also show if the user wants to manually override the system, such as if the face is not being recognized, or if we want to enter any other person whose image is not being recognized, so we can also do it with our mobile phone with the help of MQTT protocol, and we will like seeing the functionality further. Now to test our project, on the right hand side there is Raspberry Pi along with the camera module and PIR motion sensor, and on the left hand side there is Arduino Nano 33 IoT along with the actuators, solenoid lock as well as relay module. So to test our code I will upload the code, both the codes simultaneously. So the Arduino code has been uploaded, and the Raspberry Pi code it has also uploaded. So firstly we need to uh, activate by putting our hand on motion sensor. So it has stated the motion detected, camera starting. Now I will put my face on the, as it has detected Bhavik, so the command will go on, and the lock has opened along with the glowing of green LED, and the Arduino IDE has also shown the unlock command on the terminal. Now I have given the threshold of only 10 seconds, so for only 10 seconds the green LED will turn on and the solenoid lock will open. After that it will return back to its original state. Along with this, we can also see that here is recognized Bhavik, and the command send unlock and the logged event, which we will see further our event.csv. All the events that has been, like, for the non faces as well as the unknown, it will be uploaded on the event.csv, and the email has been sent, which we will check now. So this is the email which has generated 1 minute ago, and it was showing that Bhavik was granted access as Wednesday, October 22, and the timestamp. So it will provide us, this email will provide us the functionality at what time the user has logged in. Now we will check if any intruder will try to open the lock. So what will happen? Now we will see what will happen if an intruder tries to. So as it has recognized unknown intruder, our Arduino will give us a command of command alert, and the red LED has started blinking and the lock has not become open because the intruder is there. Along with this, we can see on our Raspberry Pi that email notification has been sent, and the image has been uploaded to Dropbox, which we can see through our email, like intruder alert mail has been shown. And along with the timestamp, our the link of the image has also been generated, which is for, like, which will tell us that who has tried to come. So the unknown intruder has shown like this. So this is the HiveMQ console, and this is the mobile phone, which is in which I have downloaded the my MQTT app. So if we need to manually override the system and open the solenoid lock with the help of MQTT, so we can just use the topic Bhavik Smart Door command and the message unlock remote. So when I will click that message, so it will showing on HiveMQ, and the lock has been open and green LED has started blinking. This shows that if we want to let any stranger in, so we can do that remotely with our phone. So now we have clearly seen how this system works with the known faces and unknown faces, and if we need to give entry to the unknown faces, we can give as well through the MQTT protocol. For the notification system, have also seen the email notifications of intruder as well as if the known faces has been detected, and how the image of that intruder is being provided to us with the help of that link through the Dropbox API. Now, for fault tolerance, we will see if anything fails in the Dropbox API. So how we can get the intruder details as well as the all the events, all the loggings that have been taken place. So for that, I have made this event.csv. From the start, it will show us all the details, like it is for today, like how the user has opened the lock through manual MQTT, and there were intruder, there were unlock options as well. So this CSV will contain all the details from the start, like who will enter and who has tried to connect. Along with this, there is one intruder folder as well in the local server, which is detecting all the images, like for access Bhavik, these such images, and for intruder we have seen such images. So through this we have like thus two two end storage locally, as well as we have tried it to stored in the help of one API functions also. So this is the overall demonstration of my project, smart intrusion detection as well as low control via IoT as well as cloud. So thank you very much.